lecture on chapter 2 of our course. Can you all hear me and see me and see my screen?
Yes, we can.
Yes. Yes, everything clear.
Perfect. Okay, so we're going to start chapter 2, which is motion along a straight line. Now, what we're going to be focusing on is studying the motion of objects, which is called mechanics. And it is the oldest branch of physics. You go back as far as history, not only 100, 200 years. You go back to Zaman al-Fara'ina, you go back to the Greeks, you go back to the Romans, you go back to the ancient histories. And there was always a question about how things happen. Okay. Now, if you're a fan of history or a fan of philosophy, you will notice that in history, people were less concerned about why things happen, and they were more concerned about how things happen. Because the why was a bit easier for them to understand, because in their point of view, they made up a god for each thing. Okay, so كان عندهم إله الرياح, إله المطر, إله القمر, إله الشمس, إله البحر, and they weren't as interested at that time about why is it that we get rain, as much as they were interested how can we predict rain and how do we know what's going to happen once it rains. And that sort of divides our mechanics into two portions. One is we call kinematics, and it's a question of how objects move or how things happen. Okay, how objects move specifically is called kinematics, and we're going to focus initially on the how. Then we are going to move on to the dynamics, which is, okay, we know the how, why do they move? Okay, and the why bit is more recent history than the how. Okay. Why is it not changing? There are two types of motion. One type of motion is when we go, for example, down a slide. Yeah. When we go down a slide, we have what we call translational motion. Okay. And for that, you have something that is moving very, very. I need to show you using something. Okay. You have something that is moving like this. Okay. Then you have the other type, which is rotational motion, which is when something actually also goes in circles, rotates. Now, for the first 8 chapters or so of our course, we're going to be focusing on translational motion. And then for the next 3 chapters after that, we will focus on rotational motion. Okay, with the exception of a tiny, tiny bit on circular motion, which we will talk about before chapter 9 to 11. Now, a very good question would be, okay, what about when something like a ball moves? It both rotates, when I kick a ball, it both rotates and it moves at the same time. What do we call this? Well, we call it rolling. And that is what we're going to be studying mainly in chapter 11. Okay, so now that we are done with these, here's a question. How many types of translational motion can you think of? Anyone?
A car moving.
Okay, what other types of motion can you think of? That's one type. Let's think about classification, different types of moving.
Rocket? The rocket?
Okay, rocket.
Falling.
Ball, okay. What's the main difference between the rocket moving and a car moving? Can you think of it?
The rocket is moving in 2 dimensions.
Excellent. The rocket is actually moving in 3 dimensions, while the car is usually moving in 1 or 2 dimensions only. So our translational motion, we can classify it into 1, 2, and 3 dimensions. In this chapter, we're going to do 1-dimensional, then we're going to talk about vectors in the next chapter, and the one after that, we'll talk about 2D and 3D. Okay, so 1D is something like this. When I'm looking at a train moving, the train goes on a track. It goes either this way or that way. It cannot go left and right. Okay, or up and down. That's 1D. 2D is more like this, okay, or more like a car driving. You can go left, right, forward, and backward. And 3D is more like a rocket or a helicopter when you have all 3 dimensions in play, and you go up, down, left, right, forward, backward. Let's focus on 1D motion. And this is wrong. I do not know why this is like this, but what I do know is that it should not be like this. It should be like this. Okay. So 1-dimensional motion. Car going, coming back only in 1 direction. In the x-axis, for example. 1-dimensional motion. Apple falling down. It's not going left, right. It's just falling down. So it's 1-dimensional motion in this axis. Now you will notice that I have labeled this x and y axes, but it is very, very important not to get confused by these labels. When we move on later to the 3 dimensions, you will see that this direction, sometimes we don't call it y, sometimes we call it z, for example. And that is absolutely fine. Okay? So what do? We indicate what we call the origin of the axis with an O or a 0. Okay? And we indicate what is the positive direction with an arrow. And we call that a coordinate system. What is that? A coordinate system is our reference frame. It's what we compare everything in life, or in that problem at least, to. Okay, so this is my 0 point, and everything that happens in this problem is compared to the 0 point. If it goes in this direction, I have defined this to be positive, so it will be in the positive. If it goes in that direction, I will call it negative. Here, this is what I call positive, so this is negative. Okay. Let's look at some practical examples. Let's look at distance traveled and displacement. Here's a fat person like me walking. Now, this person starts walking here, comes to the tree, moves 70 meters. Then he decides to move back by 30 meters. Now, there are 2 different terms that we use to describe, okay, what just happened, okay, or the amount of movement this person did. We can do it in 2 different ways. One way is to look at the total distance this person walked. What is the total distance this person walked?
100
140 meters.
100 meters.
100 meters.
100.
So if you are interested in something like, you know, how many calories he burned, so that would be, okay, how many calories he burns at 100 meters. Now, another way to look at it is, what is the difference between his initial point and the final point? Okay, what would that be?
40 meters.
40 meters. Yeah. المحصلة من الحركة هذه كلها كانت only 40 meters, not 100 meters. Yes, if I am interested in something like calorie burning, I will be looking at the distance, 100 meters, 70 plus 30. If, however, I am interested in something else, like, for example, say there is a race and he only wins if he steps on a button here, for example, then I don't care about the 100 meters. All I care is about the displacement. How long does it take him to get here at this point? Okay. نعتبر هذا going this distance and coming back this distance مسافة ضائعة. Okay, so distance traveled, you have all did it correctly. It's 100 meters. And the key point here is distance traveled is usually in positive values only. Okay, I cannot travel minus 100 meters in distance. Okay, I can travel 100 meters in that way, but it's still 100 meters, so distance. Displacement, on the other hand, okay, is the final position minus the initial position. My final position was at 40 meters. My initial position was at 0 meters. So my final position is 40 minus 0, which is 40 meters. What if my final position was here at minus 40 meters? What would my displacement be?
Minus 40.
It would be minus 40 meters. So displacement is a vector which has a direction. It can be positive or it can be negative. And we're actually going to be talking much more about vectors in the next chapter. So how do we write what displacement is? Well, we write it as delta x, the change in x. And is x2 minus x1, or another way to write it is x final minus x initial. If my displacement is in the positive direction, we call it positive displacement. If my displacement is in the negative direction, we call it negative displacement. Is everyone good with this so far?
Yes.
Okay.
Yes.
So let's do a PIQ to get the ball rolling and get things interesting. If you all go to Moodle, under week 2, you will find under today's lecture something called PIQs number 3. You go there, please. I'll give you all about a minute to log in and be there.
Mister, there are new students that don't know the enrollment key.
Okay, so if you don't know the enrollment key is as follows. Depending on your lab or tutorial section, and make sure you go to the correct one, because this is how you submit your labs and your tutorials.
دكتور
Yeah,
السؤال ما ظهر.
I still haven't started it.
Okay, thank you.
Okay, so is everyone on Moodle now? Anyone wants me to wait a bit more? Mariam, you enrolled? Okay, I'll take the silence as a yes. I will start the question, and you should see the question on your screen about now. Give you a minute and a half to do it. So we have 118 students in this lecture, and only 79 of you are on this PIQ thing. Remember, these things are assessed.
دكتور ايش شكل السؤال؟ كيف المفروض يطلع؟
اختر الإجابة الصحيحة. It should look like this.
The choices order is different in the quiz. Is it okay?
The order might be different for the first question. This is a problem with me coding the question, but the choices should be the same. بدون إزعاج. Okay, so I'll give you about 30 more seconds. Okay. Gathering the results. And pretty much everyone got the correct answer, which I am very, very happy about. The correct answer is indeed that the distance is 500 meters and the displacement is 0 meters. So the room is 250 meters from the supermarket. You go and you come back. Your distance is 250 plus 250, 500 meters. But your displacement, you start from your room and you end up from your room. So what is your final position? Your room. Your initial position, your room. So final minus beginning is equal to 0.
0.
Okay. Okay, so we dealt with distance. Now what about time? How do we measure time?
With units.
With units, okay. And this is
Positive
kind of
value only.
sorry?
Positive value only.
Positive value only, yes. You
No,
cannot
but
have
I need
negative time. Excellent. And
Time
we
is a
usually
We
sorry?
need the final time.
Time is constant.
Yep. And you will usually use one of two devices. We either use a stopwatch or a clock. Okay. Okay, we might use some more complicated watches, some really fancy ones, atomic clocks, you know, laser quantities, blah, blah. But at the end of the day, الفكرة هي أنه they are a stopwatch or a clock. Yeah? Now, a stopwatch starts at 0. You do a click, and it will give you the final time when you click stop again. Or a normal clock, you will start with some number, and then after, when you stop, you look at that other number and you subtract them. Either way, your time is t final minus t initial, and you get the same number, right? This is very simple. We do it every single day, nothing complicated. We come now to the concept of defining new things, new definitions. How fast are things moving, or what we usually call in day-to-day speed? So we start with defining two things. One we call speed and the other we call velocity. And in day-to-day life, when we just speak, we usually confuse the two together. Okay, but in physics, if you confuse them, you end up with a big problem, and I'll show you why. Speed is how far an object travels in a given time interval without looking at direction. So you look at your entire distance, and then you look at your entire time. You take your full distance, you divide it by your full time, انتهينا. That's my speed. Velocity, on the other hand, also includes direction, which changes things. So look, for speed, we have here distance, but for velocity, we have displacement. So for our previous example of the person walking, okay, if we say the person starts at time equals 0 and stops at that final position at 3 minutes, 180 seconds. Okay. Okay, so we have already agreed that the distance traveled is 100 meters and that the displacement is 40 meters. Now, when we calculate the speed and the velocity, which one do you think will be higher, the speed or the velocity?
Speed.
Speed.
Higher, right? Because we have traveled, it appears as if we have traveled more distance in the same amount of time. So my speed will actually be much, much higher. Right?
Yes.
Okay, good. Is everyone happy with this? So far, so good? Okay.
Yes.
Now, when is velocity important? When is speed important? Let's ask you something like this. When you are using a GPS, is it more concerned about velocity or about speed?
Speed.
Speed.
Speed, I think.
Velocity.
Velocity. Okay. So let's look at it this way. The GPS is looking at what distance?
No.
Okay.
Distance, travel, displacement.
Okay. So here's the difference between the GPS brain and the Omani brain. Okay. The Omani brain صاحبي يتصل علي وينك؟ أنا انتظرك صار لي 20 دقيقة جاهز. خلاص أنا واصل عند الدوار. دقيقتين وأكون عند البيت. أطلع. وأنا ويني؟ أنا توني طالع من البيت. إنزين؟ أنا توني طالع من البيت. أنا عند الدوار بس خلاص اطلع دقيقتين انزل تحت. وهذاك مسكين بعدين ينصهر في الشمس. إنزين؟ The Omani brain looks at displacement. أنا بيتي هنا عند A. بيت صديقي عند B. Okay. The straight distance between them is 40 meters. فأنا بوصله في دقيقتين. Okay? On the other hand, the GPS brain is like, صبر. Let's فهم. The straight distance is 40 meters, but, okay, you're not in a helicopter. You are going to drive on a road. So you're going to leave your home وتاخذ هذا الشارع وبعدين بتروح كذاك وبعدين لازم تاخذ هذه اللفة وبعدين تلف وبعدين لأنه شوارعنا في عمان مخططة بشكل ممتاز نحن بندخل الخوير ونطلع وبعدين ندخل منها على بوشر وبعدين نوصل للعمرات. So now my total distance that the GPS is looking at is not 40 meters, is not the straight line. It is
4,000 meters.
100 meters or 4,000 meters. Okay. So it is not as straightforward as we expected it to be, right? The GPS actually looks at the length of the road, which is the distance, not the displacement, which is the direct distance. Now, what if I was using a GPS in a helicopter? What would it be using then? Distance or displacement?
Displacement.
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 Calculating it using velocity, not speed. ليش؟ لأنه في helicopter I am going in a straight line. ما عندي شارع ما أروح يمين شمال. Yes?
Yes.
Yes.
Now let's define something more. Now, all we have spoken about so far is average velocity. What do I mean by average velocity? What I mean by average velocity is the following. All the calculations we did so far, we looked at the total displacement and the total time. ما عملنا zoom in وشفنا على التفاصيل، صحيح؟ جالسين نشوف على الصورة الكبيرة من بعيد. أنا رحت 40 كيلو في 5 ساعات. Overall picture. إيش اللي صار خلال هذا ال 40 كيلو؟ إيش اللي صار خلال هذا ال5 ساعات؟ I have zero information. I just looked at final position, initial position, time elapsed. That's it. Yeah. And this is what we call, V bar or V average. Okay. My velocity unit is meters per second because distance over time. If the object moves towards the positive direction, we say it's a positive velocity. If it goes in the negative direction, we say it's a negative velocity. What does x of t mean? In general, if I say something is x of t.
Function of x when we substitute by t.
Yes. It says that we have something that when I give it t, it will give me x. So this is what I get. A graph where t is the independent variable down there, and x is the dependent variable. It's on the y-axis. Okay, and I get something. I'll put xt, I'll put some units. Okay, and I will plot these. What will my slope give me?
Velocity.
Velocity.
Velocity. How fast is my position changing? Will it give me average velocity this way or instantaneous or something else?
Average.
It will give me average velocity, right? The slope will take a look at the total time and total distance, and it will give me some velocity. But there's another type of velocity and another type of speed. When you're driving your car and your car is telling you you're currently driving at 120 kilometers per hour, what kind of velocity, what kind of reading is it giving you? Is it giving you speed or velocity?
Speed.
Speed, right? Because it doesn't give you direction. If you're going reverse, it will still give you a positive number. It will not give you a negative number. So it's giving you speed. Excellent. But what kind of speed? Is it telling you the speed من أول ما طلعت من البيت لين ما أنا وصلت المكان الفلاني on average what was my speed?
Instantaneous speed.
No.
It's telling you exactly at this point of time في هذه اللحظة في هذا الآن what is my speed? At that moment. And that's what we call instantaneous. That's what we call instantaneous velocity or instantaneous speed. Okay. So in the top graph, my velocity is constant, but in the bottom graph, my velocity is changing all the time. So here, if I take my slope at each point, it will give me a different number. So what is the definition of instantaneous velocity? Well, it's actually simpler than what we think. We take our definition, delta x over delta t, صح? وبعدين I want it at this instant, at this moment. So أصغر التايم. بدل ما أشوف أوكي أنا طلعت من بيتي وصلت الجامعة خلال ساعة، بدل ما أسوي my total distance 45 كيلو في ساعة، أشوف في نص ساعة، وبعدين أشوف في ربع ساعة، وفي 10 دقائق و5 دقائق ودقيقة ونص دقيقة وثانية. And I keep making that time interval smaller and smaller and smaller and smaller until it is too tiny. What we call an infinitesimally short time interval, or an infinitesimal interval. And what that does is, we go, okay, I have delta x over delta t. I will change it from the Greek alphabet of delta to the Latin alphabet. And I will get this. And you know, we all know what this is. This is a differential. Velocity is the rate of change of time, dx by dt. Are we all happy with this?
We are.
Okay. Anyone has an issue? Anyone has questions?
I didn't get it.
Okay. Which part did you not get?
The last part.
Okay. So we have delta x over delta t, صح? What happens as we make delta t smaller and smaller and smaller and smaller? My time difference becomes smaller and smaller and smaller, and the definition of a very, very tiny time difference is the differential. So d by dt. This is the definition of instantaneous velocity, how much position changes at this instant, which is the differential, because you're taking delta t to be very, very tiny. Okay?
Okay.
Okay. So let's do another PIQ question. And this PIQ has two parts, as you can see. This is part A. Okay, on the left is part A, on the right is part B. We are only doing part A now. Okay, forget about part B. We're only doing part A. Can you see the question on Moodle?
Yes, doctor.
Okay,
Yes,
perfect.
doctor.
So I'll give you about 3.5 minutes to do this, because actually I'll give you 3 minutes to do this. Take your time. You have the question on Moodle. So I will stop sharing my screen for a second.
Doctor,
Aywa.
it's not clear on the model.
It's not clear.
Yes.
Can you decrease?
Okay, so let me share it again. Okay, you can see my screen now.
Yes, that's it.
It's the same. Well, Mariam, actually the speed graph will show you a positive value at all times. The velocity graph can give you a negative value as well. Okay, so I'm going to end the question in about 30 seconds and see how we do.
Mr.
Aywa.
This question is not appeal for me. I can't see in model.
The question is
I
shared
don't
on the
know.
screen.
Maybe.
If you can't see the question, do the options appear for you?
No.
And me, Doctor.
Okay. Anyone else? Do other people see the question or no?
I see the question.
The options are A, B, C, D.
Option.
That's it.
Yes,
Okay.
Doctor, we see the question.
Okay, so some of you see it, some of you don't. I need to see why. But the question is available on the screen. I've shared my screen, so you can see it from the presentation.
Doctor, maybe they should reconnect in the website. Maybe that's the case. Sometimes happens to me.
I honestly don't know what the reason is.
بس ظهرنا البارت الأول.
ايوه البارت الثاني بعده ما في. ما حطيته.
أنا لا البارت الأول ولا الثاني. سويت تحديث للصفحة بس بعده ما ظهر.
Okay, we can try to look again. Okay, so let's see. There was an error getting current results. Why? What was the problem? It appears I have a problem with Moodle then, because it is refusing to show me your results as well, which is not a good start. No, it has already started, you stupid thing. Yes, Mother? Okay, so we are back to the distance. No, I want the next question. And this question. Okay, this is not nice. It seems that we have a problem with okay, it still says in progress. Go to session in progress. No, but the session is already in progress. Next question. Okay, can you all submit your answers again and see if it works, if you can see the question? This is not cool. Part A. We're still at part A. The thingy got stuck for some stupid reason. So the same answer you put 2 seconds ago, just put it in again.
دكتور ما ظهر عندي البر.
بعد ما ظهر؟
حتى أنا ما ظهر.
حتى أنا ما ظهر.
Okay. Okay, let's just move on.
I reloaded the page and it was there.
The fun of having online learning. Okay.
دكتور تو نحل السؤال بارت 1 لا؟
Part 1 أيوة بس okay, so some people refresh and it works for them, some people it doesn't. We need to see why that is. But okay, most people got it correctly. Okay, so let's work with it and then we can see what the issue is. Okay, so the following equations give the position x of t of a particle in 4 situations. In each equation, x is in meters, t is in seconds, and t is more than 0. So we have x equals 3t minus 2, x equals minus 4t squared minus 2, x equals 2t to the minus 2, so 2 over t squared, and x equals minus 2. We want to find in which situation the velocity is constant. How do we find the velocity?
X over t.
X over t, and if we have a function?
Slope.
We
Derivative
Limit.
Yes?
derivative of the x.
Yep. So we get 3, we get 8t, sorry, minus 8t. We get minus 4t to the minus 3, and we get 0.
0.
Now, many people chose 0, this one, 4, to be the answer. Okay. Now, let me ask you a question. If my velocity is 0, is it a constant velocity, or is it that we don't have a velocity aslan?
We don't have it.
We don't have.
If my velocity is 0, we don't have a velocity assassin. The thing is not moving. So it's not a constant velocity, it's that we don't have a velocity aslan min al-asas. So the correct answer would be 1, because my velocity there is constant at 3. Okay, so 3 meters per second. Okay, in part B, in which is v in the negative x direction? So we're not going to do the whole Moodle thing. We're just going to have a quick voice poll. Okay, which ones have a negative velocity?
2 and 3.
3.
2.
2.
So
2. 3.
both.
2, doctor.
I think it will be minus 8.
Yeah.
So it will be 2.
2.
Yeah. 2. So both of them
The
have
right
a
answer.
negative in front of them. So both of them actually have a negative velocity. You can have more than one correct answer. In this case, 2 and 3 are both correct. Yeah?
Why 3? Why 3?
So 3, my velocity is minus 4t to the minus 3.
Doctor,
minus 4t to the minus 3 is the same as minus 4 over t cubed, right? So it's still a negative velocity,
Doctor,
for any value of positive time.
when you do the derivative, the minus 3 will be multiplied with minus 4, yeah? So it will be 12. So it will be, I think it's a positive.
We already derivative.
But that is already the derivative. The original equation was this.
Okay.
We had x equals 2 over t squared.
Yeah.
And then our v became minus 4 over t cubed. Correct? Or am I missing something?
Yeah, correct.
Yeah. If I'm missing something, sometimes I do make mistakes. So do catch me out. Sometimes I will make mistakes, and I will depend on you to tell me, no, you are, you are doing it wrong. So do we agree? Both 2 and 3 are correct?
No.
No? Okay, can you tell me why not?
Because in first equation, not minus in 3. There is no minus in 3. Equation 3.
But this is for this is for position. This equation is for position. We are asking about velocity. So when we differentiate this equation for velocity, we get something with a negative.
Number 2 is correct because it's straight line, but the number 3 is curve. The slope in each different place is not the same.
Okay, but why would that be a problem? That's still a negative velocity.
Doctor, 2 and 3, it's correct.
Yeah. So it doesn't have to be, there is no rule that says the velocity has to be a straight line. It can be not a straight line, and that is absolutely fine. Yeah, we don't have a problem with non-straight line velocities. That's very important. So 2 and 3 are both correct. Okay.
Mister,
Aywa.
I don't understand part A.
Part A, we differentiated the position, we found the velocity, and we wanted to see which one has a constant velocity. Constant velocity means it's just a number. It doesn't depend on time. So the only one of the four in which the first derivative, which is the velocity, is a constant number is number 1. It gives us an answer of 3 meters per second. Number 2 gives us a t dependence, so it's not constant. Number 3 gives us a t dependence, so it's not constant. And number 4 is simply 0, so it doesn't have a velocity assassin.
So, Doctor, if we want to get the velocity, it's always we differentiate the equation.
If you have an equation, you differentiate it.
Always.
If you don't have an equation, or if you're looking for simply the average velocity, you can do delta x over delta t.
Okay, so both is correct.
Both is correct. But in this case, for example, you cannot do delta x over delta t because you have to differentiate because it's a function.
Okay.
Okay. All right.
Doctor?
What do we understand from these graphs? So I noticed in the pre-check questions, in the reading check questions, a lot of you said you had difficulties with sample problem 2.02. This one, velocity and slope of x versus t. I noticed a lot of you said you had a problem with this. So we're going to work on this a bit. Okay. What do we understand from these graphs? What is happening? Can anyone explain to me?
The first one, the acceleration is 0.
Okay. The first one, the acceleration is 0.
The velocity is constant.
Okay, good. What about the policeman?
The acceleration is not constant. There is an acceleration.
Velocity increasing by the time. Acceleration is constant.
Okay.
This goes to the positive.
Yep. So here our velocity is a constant. Our acceleration is equal to 0, so it's the same velocity. Here, the acceleration is constant. The velocity is increasing. Here, the velocity is increasing. The acceleration is also constant.
Increasing.
Is the acceleration increasing?
No, it's constant.
No,
Constant.
No, it's constant. We'll go into more detail to acceleration in a second. Okay. But the idea that you can differentiate where is it constant, where is it increasing, is an excellent start. Okay. Now this is a very...
The difference between 2 and 3.
2 and 3 are the same thing. But one of them starts from 0, one of them starts from 2. So if we want to do a story from these graphs, what we're going to say is something alongside these lines, that our velocity, that this woman was walking at a constant velocity. The thief takes her bag and starts running. So at time equals 0, the thief is already running. Okay. At time equals 0, the policeman is not moving, the velocity is 0, but as soon as he sees the thief, he starts increasing his velocity. Yeah?
Okay.
Okay. Now we're actually going to do an example. راح نسوي مثال عملي على هذا على هذا. Give me a second. Okay. Kareem is initially walking due east. He stops, noticing a cat behind him. He runs due west and stops when the cat disappears into a farm. He starts walking due east again. Then the cat passes him and he runs due east after it. Kareem gets tired and stops running. Which of the following graphs correctly represent Kareem's position versus time? Okay, so I'm going to put this on Moodle, and this is an interesting question. So what we're going to do is I'm going to put you into breakout rooms where you can discuss with your friends and submit the answer once you have finished discussing. So I have set it so that each group has at least 4 people, sometimes more, sometimes less. Okay, and that each group has at least 2 boys or 2 girls, so there's no girl alone with boys and no boy alone with girls. Unfortunately, there's no way in Google Classrooms and Google Meet to separate the boys and the girls, but this is the best we can do. Okay, so I'll give you a timer of about 3 minutes to discuss this question, and the answer is in the
Doctor,
thingy. Aywa?
first upload the question, please.
The question is already there. Can you see it?
Yes, we can.
Yep. The question is already there. Okay, because once I open the room, you will lose access to my screen. So the question is already on there. You are 5 people in each group. So hopefully, worst case scenario, at least some of you will be able to view the question properly. Okay, good luck. 3, 2, 1, go.
دكتور
ايوه
وصلتني رسالة.
رسالة ايش؟
اني انضم في جروب كذا وكذا.
Let me see. Cannot be assigned. Why is that? هل انت على تليفون او لابتوب؟
على التلفون.
على التليفون. عامل ابديت الى الليتست فيرجن مال جوجل ميت؟
تو لحظات اشوفها بعد.
هذه واحدة من المشاكل مال الاونلاين ليرنينج، ما في واجد اشياء ما اعرف اسويها.
ماشي ما ظهر.
ماشي. Okay, I'll try to figure out what the issue is.
Okay.
Okay, pretty much everyone is back now. So this was a rather uneasy question, and even then, we have about 60% of the students or of the groups answered it correctly, which is a really, really nice thing to see. Okay, so we'll do it together as well. Okay, remember we said at the beginning of the semester that the best way to learn is to teach. And sometimes we don't understand the question, sometimes we're unsure, sometimes it's just confusing. And once we start talking to our friends, they help us out a little bit, we help them out a little bit, and it is amazing how quickly we manage to catch on. Okay, so this is a position, this is a graph of position versus time. Okay, up is east, down is west. So it says Kareem is initially walking due east. Initially due walking east means the graph needs to go into the east direction, which is up. صح?
Yeah.
Okay, initially this thing is a straight line, so it's not going east. This is not right. Initially this is a straight line, so it's not going east, so this is wrong. This is going east initially, and this is going east initially. Both are fine. بعدين, he stops, noticing a cat behind him. Okay, there's a stop, there's a kink here, and there's a kink here. So far, these two are equal. He runs due west. When he runs, what needs to happen to the slope of the equation?
Come down.
Go so fast.
It needs to be very slopey, right? Either this way or that way, but it needs to be quite slopey because there's running, the velocity is high. All right. Okay, so this is running west. This is also running west. So far, both of them are okay-ish. The cat disappears into a farm. He starts walking due east again. Now here, this is not straight line. This is going up. So he's walking east. Here, this is an absolutely straight line. So he's not walking east. He's just staying where he is, which means this is incorrect. That only leaves us with A as the correct answer. But let's keep going just to make sure. Then the cat passes him and he runs east. So again, runs east. This is high slope. Kareem gets tired and stops running, which we see here because this is a straight line. So straight line means slope is 0, means velocity is
0.
Velocity is also equal to 0. So he's tired and he stopped running. Okay, so most students got this correctly. Now, acceleration. We already spoke about it. You have already read about it, but we're going to go over it quickly. How much velocity changes in 1 second is acceleration. So average acceleration. So before that, what was velocity? Can anyone remember the definition of velocity?
Difference in velocity over difference in time.
Time.
Okay, so the definition of acceleration is difference of velocity over time. And the definition of velocity was?
Different speed over time.
Difference of position over time. Distance
over
over time, right? Excellent.
Yes.
Our average acceleration has the very same definition as average velocity, only instead of delta x, we have delta v. Okay. V's unit is meters per second. And at the bottom, we have the unit of second. So the unit of acceleration is meters per second square. Okay. Instantaneous acceleration, the exact same idea as instantaneous velocity. What is the acceleration right now at this moment, at this instant? Okay. I'm only looking at this instant, so in an infinitesimally short amount of time. And here we do some calculus, which is easy and nice, nothing complicated. Okay. We had position. To go from position to velocity, what did we do?
Differentiate.
We differentiated the position 1 time, right?
Yes.
Okay, now to go from velocity to acceleration, what do we need to do?
Differentiate also.
2 times.
So differentiate velocity 1 time, or if we don't have velocity, we can go directly from position to acceleration by differentiating position
2 times.
2 times. Like this. Nice and easy?
Easy.
Again, Doctor, again.
So to go from position to velocity, we differentiated 1 time. To go from velocity to acceleration, we differentiate another time. Because, why? If we have a graph of position versus time, the slope equals velocity. If I have a graph of velocity versus time, then my slope equals acceleration.
Mister, can you repeat, please?
Okay. So do we agree that to go from position to velocity, we differentiate 1 time?
Yes.
Okay. And do we agree that to go from velocity to acceleration, we differentiate velocity 1 time?
Yes.
Okay. So then, since acceleration is dv by dt, and v itself, now I'm just substituting, I'm not doing anything else. V itself was dx by dt. That means my acceleration is equal to d2x over dt squared. So if I had, let's do an example. If I had an x that is equal to 2t cubed minus 6, what will my velocity be?
2t square.
You forgot one bit.
60
square.
60 squared.
60 square, yes.
Okay. And what will my acceleration be?
12t.
12t.
Excellent. 12t. There you go. Done. So you differentiated one time to get velocity. You differentiated another time to get acceleration. Yeah?
Yes. Yes.
Okay. Already said this bit. Now we have time for one more PIQ. Which one should we do? This one. Let's do this one. So the question is already on. So the question is already on Moodle. The graph below represents the speed of a car traveling east along a horizontal road. Which of the following statements is true? The car initially increases its speed, but then the speed decreases at a constant rate. The speed of the car is initially constant, but then it has a variable positive acceleration. The car initially has a positive acceleration, but then has a variable negative acceleration. The car initially has a positive acceleration, but then has a variable positive acceleration, or we can't get any information about acceleration.
Doctor, I have same problem. I can't see question. I don't know why.
Okay, so I have a few. Can I try refreshing the page, see if it works? I don't know why only some students are unable to see the question. It seems like there's an issue. I just don't know what.
I do a lot of time, but I can see it.
So sometimes you can see it, sometimes you can't? Or all the questions we did today, you cannot see them?
Just I solve one question, then other question I can see it.
Okay. Can you see the options for the question? Do me a favor, take a screenshot of your
Just
screen.
white big.
Okay, take a screenshot of your screen and send it to me by email, please, so I can investigate what is the issue, what's going on.
Okay.
Okay, so we'll stop in about 30 seconds. Okay. Okay. This is excellent. 83 out of about 90 something responses are correct, which is really, really good. Okay, it means you really understood what we're doing here. So we have a velocity time graph. Acceleration is the slope. So initially we had a slight positive slope, but after that we are having negative slopes all the time, but different slopes until the car gets to a velocity of 0. So the car initially increases its speed, but then the speed decreases at a constant rate. This is not a constant rate, it's going at a different rate. This is a constant rate, a straight line. This is not a constant rate, so this is wrong. The speed of the car is initially constant. Nope, it's not initially constant. The car initially has positive, then has variable positive acceleration. If the acceleration was positive, the car wouldn't stop, it would speed up. So this is wrong. We definitely can get information about the acceleration. The only the correct option is C. The car initially has a positive acceleration, and then it has a variable negative acceleration until it stops. So this is the end of today's lecture. Thank you for being punctual. Thank you for taking part in the breakout rooms, in the oh, my